Good afternoon, folks. My name is Ranju Das. I'm the General Manager of Amazon Rekognition. Thanks a lot for spending time with us this afternoon. We have a lot of exciting information to share with you, me and a few of my team members at the back of the room. We have been working for the last year and a half, kind of busy trying to think through how to solve this problem that Andy talked about this morning, which is how do we make machine learning easy for all developers, all customers. Our charter within that has been from day one to build a managed application service for vision that can help our customers understand any visual content that their business, their enterprise, their customers, or their systems have to interact with and extract metadata from them. So as part of that charter, last year around the same time, we announced Amazon Rekognition Image. What Amazon Rekognition Image is a fully managed service, easy to use API, deep learning based, a low cost service with features that we launched at reInvent last year, which were primarily around object recognition, face detection, face recognition. And since then, the team has been busy working on that stack, building capabilities like real-time face recognition, capabilities like text in image, inappropriate content detection. So if you look at what Rekognition Image provides you, are these capabilities. Start with what we launched with, where object and scene detection, face detection and analysis, and we'll talk about these in the context of video as well, face recognition, unsafe or inappropriate image detection, celebrity recognition, and text in image. Now, since we launched, that was, again, last November at reInvent, a lot of our customers came up to us and told us, hey, it's amazing. We got this image recognition, and we are blessed to have a lot of customers who have actually deployed Rekognition at production at this point and are deriving value of our service for both their business as well as their customer. But a lot of them came to us and told us, what's your answer for video? Because as it so happens, a few providers have during the course of the last year, provided solutions for video, and they wanted us to know what we are doing for video. Well, the reason that question is very important from the customer perspective is the growth that the video has seen, be it for media and entertainment, and the expectation is that by end of 2021, there's going to be 209 million viewers watching on-demand video content, right? If you look at the public safety domain, access to cheap, high-definition IP cameras has completely blown the numbers out of water here, where we are expecting, even by end of this year, to have 859 petabytes of video generated per day. To give you a context, that's round about 200 million one-sided single-layer DVD a day, right? So, and if you look at smart homes, we expect in the US, by end of 2018, there'll be at least 45 million smart homes where more than 70 to 80% of the smart home implementations are video and camera sensors. So the data is growing really rapidly. It's hard to analyze this data. And customers asked us, what is your solution? So from their perspective, why is it important to have a solution for video analysis? Because what we found in talking to our customers, in talking to our partners, was that the analysis of video helps in things like enhancing your safety at workplace or business or for your enterprise, right? If you're retail, video analysis can help in reducing shrinkage or break-ins and things like that. It improves business operations, be it logistics, be it fulfillment center. It immensely improves your business operation and productivity. If you're a retail store, if you are providing an online experience which is visually rich, it can help you improve customer engagement as well as deliver high-quality customer experiences. Finally, for the smart home, because we talked about the smart home, it really helps you deliver very personalized, safe, and secure, and delightful experiences to your customer if you can analyze this video. The challenges that the industry has faced so far, and till date, has been that the video analysis process has been largely very, very manually intensive. Even if there are some providers that have provided solutions, they still need a lot of manual reviews and checks and confirmation of this data. Because of that manual intervention needed and human in the loop, they're typically slow. And as we have learned through the course of our building product, that human entry can be subjective, right? My understanding of wedding is limited to what I know of wedding. And if you give me a bunch of videos or images of different parts of the world, I might not recognize this wedding because I don't know those cultural contexts. So they're typically subject to being slow as well as error prone. And finally, they're expensive. They're really, really expensive. Well, our customers are really creative, and they're, we are really, really humbled to have brilliant customers who find solutions for themselves and work with us to solve their problem. A great example is C-SPAN. The use case that C-SPAN had is that they have a lot of these videos where politicians are standing behind a podium and talking, and they wanted to recognize these politicians in these videos. And C-SPAN was spending tens of thousands of hours every year for human being to go in and annotate these videos with politicians that they wanted to recognize, about 99,000 politicians within the US. So what they did to reduce that kind of workflow time to get real-time, almost near real-time annotation of these videos, they became very creative. They took the video, started extracting frames per second of the video, took that frame, passed it to Rekognition image analysis, and did face recognition or celebrity detection and found these politicians that they were looking for. Now, what's interesting about this story is that not only did C-SPAN solve the problem for themselves this way, as it so happens, the other video solutions that are out there from other providers are doing the same thing. Now, the limitation of that solution is inherently based on image analysis. And what we have learned as we kind of embarked on this journey, and our first instinct was, oh, that's awesome. We have image analysis service. Why don't we do the same thing? Why don't we just take the video, extract frames, pass it through our image recognition, and have an easy product out for all of our customers? As we started playing with it, we realized, and some of our scientists already knew this and had been telling us, that image and video are intrinsically different. And why is that? It's because if I were to take a camera, I brought a DSLR here. I should have done that and taken pictures of you guys. If I brought a DSLR and pointed at you, you'd immediately pause. You would pause, because you know I'm trying to capture a still motion. Now, at the same time, you'd have video camera here, which some of them have. I'm not pausing. I'm not being still. I'm moving because I know the video is capturing my motion. And because of the frame rate these videos generate, it matches with our eye, and I still get this high-resolution output. Now, only exception being my mom. Every time I point a video camera at her, she freezes. And she stays there. I'm like, Mom, I'm taking a video, but it's very hard for her to understand the difference. But for most of the others, you really understand the distinction between when an image is getting captured versus when people are taking video, and the quality shows. So if you took a frame of any video, and you could do the experiment yourself, and do a screenshot, correspondingly take a same moment, you have taken an image, you would see there's a lot more noise in the video frame. There's a lot more blur, a lot more motion aspects that shows up in the video frame that, of course, you're not losing that quality because you're limited by the image analysis. The other aspect that you lose is temporal information, right? Because if I only take any random frame, all the other time information that happened, that a fact that I moved from here to there, and the time sequence could be lost in that. Motion context is absolutely lost, right? Because if the distinction between whether I'm waving at you or I'm keeping my hands next to me is kind of lost because you can only get a snapshot. And this could either mean I'm high-fiving you or I'm waving at you, right? So what we did, we went back, we put our best of the scientists together in a room, we got our engineers in a room, we said, okay, what is the right solution? and we came up with, and as Andy announced earlier this morning, what we are calling Amazon Rekognition Video. Now, Amazon Rekognition Video is a first-of-its-kind service which is using the entire context of the video. The visual, what, the time, when, and the motion, how, to get you rich metadata from this video that you could use for extracting insights from this video for your consumer, for your business, or for the systems that you own. The key features that we are launching with today is generally available this morning is object and activity detection. Now, all of you are quite familiar that you've already used recognition image, would be familiar with what object and scenes are. This is the notion. If I took a video of this room, it'll tell me, object detection can tell me that this is a conference room. There are tables, there are chairs, there are people, there are TV screens. Awesome. Scene would give me a sense of, well, this seems like a meeting event happening, and it's an indoor. Activities is a new thing we are introducing with video, again, because of being our ability of using the motion context of the video. We are introducing this concept of activity, and here it is saying Ranju is walking in this video. And these other folks, they are being forced to sit in this video because they have to bear with Ranju for the next 45 minutes, right? So that's our object and activity detection. Next, we have person tracking. Again, a very unique feature we are able to deliver because, again, the full context of the video that we are using. In person tracking, we are able to track an individual, every individual in a given video, even when they're partially or fully hidden for a period of time. So think of a crowded scene when somebody's walking, goes behind kind of the line of sight and reemerges. We are able to track them. If their face is seen using facial context, we are able to even track that individual if they left the scene and came back in. So think of the value of this. If you're a retail customer, you're trying to provide a video solution for your customers, for the store experiences, it doesn't matter where your customer is moving, you can now very, very high accuracy track them. If you're public safety, and I were to try to trick you guys by going under this thing and come back with a different jacket, you'll still know me as Ranju. The next set of features we have is around face recognition. Now, this is something, again, we are very, very proud of to announce to you that we are supporting face recognition for video, both for stored video as well as live stream, and we are able to do that for face recognition against collections of tens of millions of faces in real time. We, of course, support real-time live stream, again, a unique capability that you'd only find with us, and we are able to do this because, again, the full context of the video is captured by us and is used by the system. Much like the other two capabilities that we had in image, we have here as well, is unsafe video detection or inappropriate video detection. And the idea here is that given a video, we'll tell you where, if there's any explicit content, there is any suggestive content. We'll also give you a richer taxonomy of why we thought it is explicit and why we think it's suggestive. Finally, we have celebrity recognition, and we are not a very proud organization. We are supposed to be humble. The only reason we use Jeff's face here is that we are also supposed to be very frugal, and we didn't want to spend the money on celebrities here, so we use Jeff's face. So if you look at the solutions that are out there today, other providers, they have solutions for stored video, which is videos that you've already archived in some storage place, or you could upload, and they can analyze that video. But a lot of our customers say, well, that's only one part of our problem, because a bigger source of the data is all these IP cameras that are all over smart cities, all over homes, all over retail stores. How do we not wait for the data to be stored and archived and then get analytics? Why can't I get the information from the live stream? So, well, we are now providing Amazon Rekognition Video, which is truly a solution for all your videos, be the video stored in Amazon S3, and the sort of use cases we are expecting customers to solve, and customers are already solving, is you can create a media search index. So look for all videos where there's a certain event is happening, or a certain person of interest is there, or a celebrity might be there. Unsafe filtering, right? Inappropriate content. Take out, remove all content that are explicit or suggestive content in them. Or just investigative analysis if you're a public safety organization. to say, hey, this event happened. I want to see who were there in this event, how they moved around, where they came from, where they went, what are the faces, who do they match with, is there a missing person, is there a person of interest? And the new capability that we have is video live stream support, working in integration with Amazon Kinesis video stream. So, and I'll get into the details of how this integration works. And the use case again here is immediate response for public safety, right? We'll talk about some customer references, and we'll get into the details of what that means, as well as you want smart home monitoring. You want to monitor your baby, whether they're crawling or not. If you want, monitor seniors at home, you want to monitor who's coming through the front of the door. All that can be done in real time with Amazon Rekognition video live stream support. So let's get into the features a little more. As I talked about object, scene, and activity detection, if you could see this is a capture of a real video that have passed through our system. The black ones are objects that we have found in the video, that we've found that there's a person, there's a female, there's a beard, there's a cake, there's a glass. We also found that, using the motion context of the video, that the person is blowing a candle and somebody's drinking. So the distinction is very, very important here, right? Because I could hold a glass, which I mostly do because I'm not a really good drinker. I hold a glass and look cool and cheers people around and never finish my glass. That's not quite drinking, is it? Whereas if I take the glass and put it in my mouth and bring it down, that's drinking. And you could only capture that if you get the full context. So that's what we are able to do with our. Get into the specifics. One of the key difference with video is videos are normally fairly large, right? Depending on how much video you want to process, how big your files are, and there's an inherent asynchronous batch processing within video because of the size of the payload. So we are introducing this concept of starting a job, starting a particular process. In this case, the API is start label detection. And once you do that, you provide us a S3 file. We go in and we start the analysis process, and then we provide you a job ID, and then you could then come back and do a get label detection, call the get label detection to get the metadata for this particular video. Now, if this job, if you've given us a really long video and the job is still running, you'll also get the job status back saying that it's still in progress. If the job is complete, we give you information in two different projections. One, we give you the natural time series projection, which is at time 0 this happened. These are all the things found. At time 1, like that. Or you could remove the projection, and you could say, in the order of appearance, the objects or scenes or activities that showed up, and all the times that they showed up. So two different projections. We allow you, much like the image, we are really focused on making sure our APIs are easy to use. You get lots of controls. Even given this, it's an application service, we still want to provide a lot of control back to you. So as an input, you could provide us min confidence, which would allow you to control the amount of recall you want from this system. As well as you can tell how many labels you want out of the system so that we could control all that stuff as input. The next feature that I want to get into the depth of is person tracking. So again, if you could see here, we correctly identified this 4 different person, and those dotted line behind each of these, color-coordinated dotted line behind each of these person, is really a visual implementation we have created using the midpoint of the person detection, and we'll talk about the details here, to show you how we can track an individual as they're moving around the scene. And there's a demo I'll show later for this video. So the two APIs that we have at this point for person tracking is start person tracking and get person tracking. In the get person tracking, you get a person ID. So within a given shot, it is expected to be unique for a given individual. The bounding box for that person. So our person tracking would even work if you don't see a face. So if my back is turned to you, we still be able to recognize me as a person and track me. So it's not reliant on the face recognition, but if a face is available, we'll give you the face bounding box as well. So you could do face searches and other stuff in workflows later. Talked about face search. Here, this is again a demo I'll show you later. We are able to detect a face and recognize a face and match it against a collection of faces. Now, before I go further, let me introduce the concept of collection. This is something we introduced with Amazon Rekognition image launch last year. The idea here is that you could create a collection of tens of millions of faces where each face is nothing but a crop of an individual, and you could get many crops of me and create a collection. So we have created a collection of all our employees. So as people are walking in, we'll know if there are Amazon employees or not. Now, once you create that collection, then you could search for, in a given video, people from that collection. So think of a collection of missing person database, right? So if you have a collection of missing person, you could have a police body cam walk around, and as they're real-time walking around, you could match against a missing person to see if the police is walking around and if in that scene, if there's a missing person there or not, right? And you could do this in real time today. So we support face search in two modes, both live stream mode as well as in the stored video mode. For the live stream mode, the semantics goes something like that. You create a stream processor, and this is basically you're creating the configuration. We work with Amazon Kinesis video stream that was launched this morning. So idea here is that you have hooked your cameras or your HD cams or your monitors into Kinesis video stream already. Kinesis video stream would then give you an identifier for the stream that you're running, which we call stream ARN. You would provide us a stream ARN, so we'll start tracking that stream. And you also provide us how you want us to notify you back, which is another Kinesis data stream that we will post all the results in. So now, as that happens, the next step for you is to do a start job. The moment you do the start job, start stream processor, we'll start picking up the streams as they come in from the Kinesis video stream, analyze it, search for the faces you're looking for, and return you the matching results through a Kinesis data stream. And I'll walk you through an architecture of how one can implement such a thing for real-time thing. Face search against stored video. It's very similar pattern that you saw before. You start a face search and you get face search results. And here we provide you some the face bounding box, some key attributes of the face, as well as who does it match with. So in this case, if it was you were trying to match a video, you took a video of me and matched against our collection of employees, you'd say, oh, I find Ranju Das in this video. Finally, again, being frugal, Jeff's the only one we use here. We can detect and recognize celebrities from videos as well. And the API pattern is very similar. You do a start celebrity, and then you get celebrity, which gives you the celebrity metadata. We have inappropriate or unsafe video content. Now, here what we do is that we provide you that, in this case, we say it seems like there's suggestive content in here. And we also provide you the taxonomy, why we think it's suggestive. Our taxonomy allows that hierarchy. We say it's a suggestive content. We found a female swimwear in it. So you're now, as a developer, you could have your own decision whether you want to allow this data video or not, right? Because you have more information here, and you could have rules based on what sort of suggestive content that we are returning back to you. Similar pattern, and then we just provide you those labels with timestamp and confidence, which is a common theme across all the APIs that we have in our system. So let's talk about why we are so excited about it. We are so excited because in Amazon, engineering and science, we are doing a lot of innovative work. Andy talked about this morning as well. But what excites us most is the fact that we are building solutions that meaningfully helps our customer, delivers efficient, high-quality products, features, and solutions for their customers, right? So in this case, if you look at the media and entertainment industry, using Rekognition video, you can create metadata for celebrities, for emotions in the video based on the face that are in the video. If you're looking at different social media data, the key topics or objects or scenes and activities from the video. And with time series data, now you could create a searchable index, which means if you're a media and entertainment company, your producers are typically looking through thousands of videos trying to find that one perfect video that they want to either have or send it to your customer. Now they could do a simple search lookup, and instead of looking for tens of thousands of videos, it shortens the list to maybe 5, 10 videos, right? Filtering is important as more and more user-generated content, and as most of the media and entertainment industry is dealing with a lot of user-generated content, it's becoming very, very important to be able to filter content because they don't have the production quality that they'll typically have and the ratings that they'll have if it was controlled by them. So to that extent, having inappropriate content detection happening automatically out of video is a very, very important enabler for them so that they could filter and restrict what content is going in front of their customers. They can also extract live stream data in live stream. So think about the live event and live stream has become a major thing. And if there's a set of musical concerting going on and the different performers are coming up in the live stream, they could in real time annotate who the performer are, and from that maybe even key into details about them and their other music and so on and so forth. And that can be done now with face recognition, real time face recognition against live stream. So how would one, if you're trying to, we talked about search index, how would one create such a thing? What we are seeing customers do is that they would get the video. The videos are uploaded to S3. Again, this is a stored video use case. The video is stored into S3. You could either have your own EC2 host processing this video, or just use AWS Lambda. We have a trigger function, easy enough to do, and call recognition video. Object and scene detection and face recognition, as well as celebrity recognition, get the metadata back, store it in DynamoDB for durable store, and then use Elasticsearch for providing search lookups. Now, if you look at the enablement here, if you're a media and entertainment company, and if most of your videos or all of your videos are already stored in S3, you could implement such a thing in a matter of few hours to a couple of days, right? And that, I think, is really important because a lot of things what we have done when we are designing this system, we knew we are designing a system that inherently deals with big payloads because videos are large, a lot of gigabytes and petabytes and terabytes of data to process, and we wanted to make it very, very easy for you to process the data quickly. So if you have a large set of data, you could even bring in AWS batch here and do a batch processing of this video using Amazon Rekognition. So that integration of the rest of the AWS, a seamless integration of the rest of the AWS infrastructure makes it so much easy for you to have this insight into your video in a matter of days or hours. Moving on to public safety. In the public safety, the primary uses that we are seeing our customers are doing are the ability to recognize a person of interest against a collection of millions and tens of millions of faces from hundreds of cameras. So one of our launch partners, and we'll talk about it, City of Orlando, that's the exact problem they're trying to solve. They're trying to solve in public places, city-authorized cameras. They want to know if there's a person of interest that pops up in front of the camera. They want recognition. They're using recognition to get real-time recognition against different collections. Could be person of interest, could be missing person, could be even people that they really want to make sure they're secure, celebrities and whatnot. And they get that notification, and they want to alert the local law enforcement officer so they can react quickly. So that's immediate response, right? So the idea is that they want to respond immediately to an event or people showing up or things that are happening and have the law enforcement officers respond quickly. The second use case is really more of the investigative nature, which means now an event has happened, and they want to investigate what happened, how it happened, who caused it. So what they do there is that they find all these videos for that particular location or particular event, they're using AWS Batch, they're calling Amazon Rekognition. We are generating the tracklet for each individual in these videos. So now they can track how somebody entered the scene, where they went, how they moved around, who they interacted with, who are these people. We can recognize person using face search now. And that's really, really useful for them. And we were talking to them, and one of the problems they were saying is that whenever they have to look into any of this investigative problem, 95% of the data they know they don't look at, because for some events, they might have 10,000 hours of video. And it's manually impossible for them to look at every moment and filter and validate. And so what they do kind of random sampling and say, okay, do I get data? And then if they get lucky, they get the right video. If they don't, it just draws on. To be able to do that across tens of thousands of videos, again, very quickly at a low cost, is really imperative for them to provide the sort of support their law enforcement teams and public safety teams need. Finally, at times, if you are in an area, restricted area, you don't want a truck coming to it or a car moving over there, or you don't expect a person to be in this area, our object and scene and activity detection can help them with those sort of filtering and analysis and detection, so that they can create notification, again, based on, hey, I'm not expecting a car to be here, and the car showed up. So let's just alert somebody to see if that's an okay thing. So let's look at a couple of implementation workflow for this sort of public safety. I talked about the immediate response. So you have a live street camera. Could be a traffic cam, could be a camera on a public place. Streams a video into Kinesis video stream. Amazon Rekognition video stream processor would get the video stream in real time, do face recognition against the collections that you have asked us to search against, and return back in a Kinesis stream all the matched faces and the other detected faces. You could use AWS Lambda to have a consumer for this Kinesis stream that then finds this metadata, processes it, and then use SNS or any other notification service to send pager to the page that was set up to go off if you found a matching person. The investigative face search use case would be something like this, where you have a lot of video stored in S3. You identify the bucket, or you move all the videos that you want to analyze in a bucket. You give us, using AWS Batch or Lambda, you give us that bucket information or all the video files. You pass it through Amazon Rekognition. Rekognition searches against the collections again, finds all the matches, and now the API response can be then streamed into a visual display or a dashboard, so you could see who are the matching faces, who are the people in this video, and start taking some action based on that. Home monitoring, the two things that comes into mind is that you want to make sure your home is secure. And security and safety of your personal space has two dimensions to it. One is intruder detection, or just normally your guests showing up, friends showing up, being able to detect them, recognize them is very, very important. And then once that has happened, also when you're home, inside the home camera, you want to monitor what's happening inside the home, right? You want to monitor activities, you want to monitor objects, you want to monitor if there's an intrusion inside the home. And Rekognition with Livestream can help you deliver for your customers a real-time face recognition for things like doorbell cameras. So you could now, in real time, we are playing with even the deep lens that we announced this morning. It's already hooked up to AWS Rekognition, and you could, pretty easily build a live stream that you could do face recognition and put it in front of your door. And then finally, activities from home cameras, right? So you have a lot of these cameras have popped up, and they all want to know if your kids are crawling, if they're seniors at home, they're falling, who are walking around, what are the things that are moving around, if your pet, did the pet move, and things like that, and we can now do that with Amazon Rekognition. Other applications that are interested and are starting to work with us are photo and video sharing apps wants to have very easy filters so that they could give their consumer really high quality experiences of, hey, these are seems like your vacation photo versus videos versus these are your wedding videos, things like that. Retail stores are a really, really use case for us. It's kind of an extension of the public safety use case where you want to track people. You want to capture the faces and get the emotions of your customers so you could react to quickly. So if I'm standing in front of a display at store and I'm confused and I look angry, then ideally you might want a customer service agent get to me and ask me if I need help, right? And you could do that now using our live stream support. Other thing that customers want to solve is that how many people came in? Right? What is my queue depth? Which is the busiest part of the store? Where are the crowds going? Where are people? And you could do all this with our object detection and activity detection. Now, manufacturing plants are another example. And Amazon itself have been doing this for a few years now, that our fulfillment centers use a lot of video analytics to optimize, to make it efficient, to make it safe. And we expect customers to do the same for their locations as well. So one other thing that, gonna do a quick demo here. These are videos that we have actually taken working with our partners, and we have passed through our APIs, and we have stylized the visualization so it's easy for you to understand what's happening here. The key enabler here, again, something that I want you guys to live with is that the key enabler here is that if you look at the top two differentiators of our product, one of it is the fact that we are now able to support live stream along with stored video. The second is our person recognition, our person tracking is using the full context of the video, whereupon even if a person is leaving a scene, coming back into the scene, if a person is hidden partially or fully behind another person or a pillar, we can track them through that with a fairly high accuracy. And you'll see some of this in this video as well. All that means is that your ability to react to a situation, your ability to investigate a situation, your ability to filter a video or search a video becomes that much higher and that much easier. So with that, this is a video from a traffic cam that we've collected from a partner, and we ran through our API. Let's look at it, and then. So if you could see, as we started detecting the person 1 on the right corner, we actually don't see our face, but just through the tracking of the body, we are able to create the tracklet for this person, where you can see this blue dotted line on the right side. If you paid attention, as the person 2, the green leftmost person here, when this person emerged from the car, for the most part, his body wasn't shown. Only a part of the head was shown, and we are able to still track it. Because using both face detection as well as person detection, we are able to merge these together to have a very, very high accuracy person tracking, even if they're partially or fully occluded behind other objects. And then if you look at the consistency of the tracklet, we are able to track their path very, very high, with very high accuracy at this point. Now, this was a stored video use case. So the other thing we are able to do is also extract objects and activities here. It was getting a bit crowded, but the objects that found in this thing was cars and dog, the key ones that kind of stands out, so I wanted to show it to you. We also detected that there's an activity of walking happening here, right? Now it's important, right? Because if in this scene you found somebody was running and in a different direction, maybe that tells you something. Maybe you need to then zoom on to that person. Maybe you need to find that person's face. Maybe you need to then go and recognize if that person is in a known database that you are tracking for, right? And I think that combination of person tracking with activity detection, and the combination of those two with object recognition and then face recognition would allow you to use this video and find a lot of information that would have been very, very hard to get otherwise, right? Or would have needed a lot of man hours to go through manually and look at each segment and get that metadata for you. The next use case I'll show you, this is a live stream from device in front of a home VS setup, and this was streaming the video into Kinesis video stream. We, of course, intercepted the Kinesis video stream and provided the face matches. And the use case here is that in my home, I don't get a lot of visitors, but mostly a few set of family members and friends come up. And the idea would be that if you, as a provider of one of these devices, allowed me to upload a set of pictures that I think are safe people to enter the home, I want to have that, because I do have a smart lock at home now, which can be using Alexa or using different other mechanism, can be automatically opened and closed, locked. What I could do is I could create a collection of my family and friends, and as they neared the home, and if I can match the face with high accuracy, I could say, hey, don't bother them, open the door and let them come in, right? And so we experimented with this, and as a result, in this case, we had a family show up. Only the dad of that family, his face was in the collection. The other members of that family wasn't in our collection. And see what happens as we are processing the live stream. Now, again, this was the live stream data was put together and then created as a visual, bit stylized visual representation for you. So if you see the difference between searching to matched, it was about 500 milliseconds or less, because that's exactly the time it took for the API to match the person and then say, hey, this stream, I found the person. Finally, we talked about media and entertainment, and we talked about how the ability to create really rich metadata that could be used to create search indexes would really help discovery for editors and producers, discovery to create new content for your customer, which otherwise you would never been able to create, and finally discovery so that you could do audits. So let's look at how that plays out here. So here you see this is a party event taken from a smartphone, and we're able to do these objects like cake, party, there's a party hat. These are all objects people who have used our system with image is used to. But at the same time, I don't know whether you guys paid attention, two objects popped up, two activities popped up, the hugging, which happened in the corner, as well as opening present, which happened in the front. So we are actually able to detect these activities using our activation of this capability. So now this metadata could be so useful, right? Because if you think of tons of personal home videos or videos that user-generated content, and if it's a home video, I'd like to see, hey, my kid's opening presents. Very easy to do now. So we are very, very fortunate to have these awesome customers that worked with us hand on hand, provided us a lot of useful feedback, was with us every step of this thing, and helped us get the product to where we are able to announce it to all of you. The key one of them is our City of Orlando, and again, the public safety tracking and face recognition use case for cameras they have in all over the city for safety of the citizens. Butterfly is a smart camera that they're trying to provide real-time alerts for business and consumers. Again, they're working very closely with us to get this to their customers quickly. Washington Post is a media and entertainment use case. They have tons of images and video. They're already using image recognition for their image use case, and they're now rolling out the video use case through object activity and celebrity recognition. Motorola Solution, Body-worn, and ARM, they are all kind of in the same domain where they're trying to provide solution services to camera manufacturers and building their own cameras, where they want to create police body cam, dash cams, and provide high accuracy metadata for these sources of videos. As Andy said, we are generally available starting this morning. And at launch, we are available in this 3 region. We are available in US West Oregon, which is, for those who are developers, you know this as US West 1. We are available in US East North Virginia, that's US East 1. And then we are also available in EU Ireland, which is EU West 1. We have a region rollout plan, hopefully have this soon in other regions as well. How much does this cost? Well, we realize that video is a really difficult thing for people to understand. Do we do gigabytes? And we realize the best thing to do is to have the transparency where you pay as you go. We provide a very aggressive free tier for you, which is 1,000 minutes of free tier per month for the first year of your using the service. For video analysis that are stored in S3, we charge you 10 cents per minute of video. So you know exactly how much it's going to cost you if you were to build a service around our product. And then finally, for stream analysis, we are charging 12 cents per minute of video for our stream API. In closing, the key benefits for Amazon Rekognition Video, besides a major benefit, which I think a lot of the managed services, application services that we are building, machine learning application services that we are building, we have spent a lot of time to make sure that it's deeply integrated with the rest of AWS. Because as it so happens, each of these services discretely are very valuable, but they need to maintain the context of security, right? Your privacy, your other application needs that you have, access to your S3, access to your IAM roles. So we have made it very, very easy. And the deep integration with Amazon S3, AWS Batch, Lambda, Kinesis Video Stream makes it very easy, low cost for you to deploy this pretty immediately for your workload. Beyond that, I think the key benefits that we want to call out is that we are one of solution that is providing both real-time and batch analysis. We are probably unique in the sense that we are providing true video analysis using both the motion and the time context of a video. Using the data that we are getting from within Amazon, as well as working with our customer, our service is continuously improving. The fact that we do live stream support enables a lot of use case which so far was locked out, because there's almost a huge percentage of the content that's getting generated is coming from these live streams, and enabling that has really makes it easy for you when you think of video. And then finally, it's also, we believe it's low cost, and it's very efficient for you to use it. Before I move on to QA, if you want to get started, please visit our aws.amazon.com/Rekognition getting started, or we have the developer guide there. We have the AI blog that helps you understand what the product is. And with that, I really want to thank you for spending the time with us. We have about 12 minutes. Anybody have any question, please feel free to walk up to the nearest mic. Is there a mic on that side? OK, there's only one there. So, or if you could shout out, I could repeat the question for the rest of the audience. Thank you. Thanks, sir. So we price based on whatever stream we are processing, how many minutes of stream we process, right? If your camera already has a motion detector and you want to use that to choose which streams you really want us to process, that's how, and we can work with you to figure out how to kind of partition that a little bit. And that's the expectation we have, because a lot of these cameras have a lot of local capabilities that you could use to choose which streams you really want us to process, as opposed to processing every stream that's coming out of the camera. Does that make sense? The question is there a minimum resolution? Yes, there are. And they're documented on our website as well. You could go look it up. It depends on the condition a little bit, right? So it's a very crowded scene higher resolution image would get you better, higher resolution video would give you, of course, better results, right? If it's a bit more localized, a sparse environment with, prominent face and whatnot, a lower resolution video might also give you very valuable results. So I think it really depends on the use case. But we have built it to support, real video sources, right? And we have built it to support a wide range of this, resolutions and sensors and positions. So based on your use case, we could figure out what is the right sweet spot for you. So the question is, how about security and privacy if the devices are compromised? People can track other people. Well, if the devices are compromised, people can track other people even without Amazon Rekognition. So I think we should talk to the providers of those devices at that point. Insofar Rekognition is concerned, as is with any other AWS service, the data that you bring in, the data that you process is secure and private, only accessible to your account and the customer account. It's customer data. So to that extent, as much as we might use this video for enhancing our service and enriching our models and whatnot, but we don't publish this video, we don't share it with other people. So it really, your data privacy is still yours.
Which cameras are currently supported, or is there a preference on, would you work with any IP camera, or because we saw the smartphone video?
So the question is which cameras are supported. We don't have any restriction, right? If I can get a live stream from Kinesis video stream, we can pick it up. So the question is, which cameras can send a video stream to an AWS service? Is the restriction here? I know the Kinesis video live stream team has producer SDKs for a lot of devices. And so any device where you could put in the Kinesis video stream producer SDK will be able to plug in and get the data from that. So the question is, can you cross-match between images and videos? The answer is yes. And we spent long and hard thinking about it. The idea of the collection is a set of faces, right, that we have found either in a video or in an image. Today, we don't allow you to index a video directly. For creation of the collection, we still take images as the only source for creating that collection. When you do get a match, in the fullness of time, we want to tell you that, hey, you're looking for this person was available in all these images and all these videos. And having a single collection allows us to do that. So yes, we absolutely want to support that use case.
So you have person tracking, but are you going to introduce like animal tracking or other object tracking, like tracking in car and things like that?
So the question is, we have person tracking, and we didn't talk about object tracking, if you may. That was a conscious decision we made. We wanted to really focus on high-quality person tracking. Without predicting future, it's easy enough to speculate that we'll soon have other tracking as well. And I think, as in Amazon, part of the burden we carry is making sure we, are meeting your trust. And we only deliver products that are high quality. Again, as I said, it would have been very easy for us to just use the image pipeline and deliver a video solution to you. We didn't do that. We resisted. We waited for a year. We built this solution a year. A lot of my team members are here. They've been working tirelessly to build this up. And I think we have a plan for object as well. And as soon as we do, we'll get it to you.
Do you do any audio analysis?
The question is, do we do any audio analysis? Today, we don't. If you paid attention to Andy's keynote, there's a bunch of language services we have announced today, right? We've announced transcribe, translate, comprehend. What we're working on is we know how to extract the audio. It's easy enough. We are already extracting the audio. We'll plug into these services, pass through the cost for you and get the transcript back to you. And then eventually maybe even able to do a translation, but that's not available in the product today. And we are aware, and we are very mindful that that's a very important enabler for our customers.
Also in terms of even sentiment analysis or activity analysis, is somebody yelling, is somebody laughing, is somebody...
Absolutely. We believe that inappropriate content or unsafe content detection has to bring in language, right? Because if somebody's using foul language, it probably becomes an inappropriate content. So absolutely, in every aspect, be it detection, the common thing, metaphor I keep using with my team is that when there's a disaster, human being typically runs away from the disaster, which means if they're carrying a sensor, the sensor is looking away from the disaster. What you get to hear is the description of the disaster. People are shouting fire, or people are saying, oh my God, there's an explosion. So I think using the auditory input to detect activities, to filter for inappropriate, to give you transcript will be important part of the product. And we're working on it. Don't have a timeline to share with you. The question is, how do we detect what are unsafe? Yeah. The question is, how do we detect unsafe? So we have a taxonomy that is actually available. You could look it up. And we have applied the same taxonomy for video. And today, when we say unsafe or inappropriate, it's mostly visual. To the previous question, it doesn't include any of the auditory input. And what we mean by unsafe is, hey, there is things that we do are, full frontal nudity, right? Male or female, or partial nudity. There's swimwear. So we're using these visual context to decide if there's inappropriate content or not. The next question that I get a lot from customers is that, violence, and do we detect violence? Today, we don't detect violence. And my sense in the, again, fullness of time, that'll be a inappropriate content or unsafe content that we'll recognize as well. Does that answer your question? Now, if the hugging is happening between two fully clothed people, we don't think it's unsafe. If the hugging was happening with, partially or not clothed people, that probably would be unsafe video. It's a sensitive topic, so sorry, half the time I don't know how to respond to these questions. Have we discovered an upper limit on the number of objects and faces? On objects, we don't have upper limit. The upper limit is the objects that we support, because we have a packaged taxonomy, right? Our ontology is fixed. So we have thousands of labels and hundreds of activities now we support in the system, and so our system is kind of limited within that output. On faces, there is a limitation, and the limitation is in more based on the latency and quality than the capability of our system. And so our guidance is, hundreds of faces we are okay with, and we have, I think, tested with up to 300 faces in a particular crowded mode. Beyond that, we actually haven't verified how well it does. But we know within that our quality remains well.
2 minutes. Can you recognize the age or gender of the person?
The question is, can we recognize age and gender of the person? The answer is yes. So we have any feature that you see in the image side. So in image face analysis, we have gender, age, emotion. All of those we have brought in for video analysis as well. So if you detect a face and you could do a face search or a face detection, you'll get those attributes back as well. Any other question, folks? Yes. So Deep Lens, out of the box, allows you to stream into Kinesis Video Stream. Once you know what Kinesis Video Stream, then just start a stream processor and you're good to go. Have we tried this on sports? Yes. Actually, a bunch of our activities, because a lot of the media and entertainment content is sports. Which sports we support is something I think we should work with a given customer and figure out. I was testing cricket. We didn't do that well. But seems like most other American sports we are doing okay with. So, but that's something we could evaluate as we work with the customer as to which sports we do well with and which we don't.
Besides Deep Lens, are there other products that support Kinesis?
Beside Deep Lens, if there are other products support Kinesis video stream. Kinesis is providing an SDK. And if you can get that SDK working in any device, it supports Kinesis. It's really as simple. We just have built in the Kinesis SDK in Deep Lens. That's all we did. All right, we're out of time, folks. Thanks a lot for your time.